NASA says its Voyager 1, the most far-off human-made object in the universe, is sending usable records to Earth once again. Inside the universe, we have no understanding of what it is, besides the fact that we can measure it. Voyager 1, the notorious space probe launched by NASA more than 4.5 decades ago, has recently transmitted a message that has sent shockwaves through the academic community. After traveling nearly 14 billion miles from Earth, Voyager 1 has made a discovery so tremendous that it has shifted its mission, pivoting toward our planet. Join us in this astonishing experience. 7 minutes ago, Voyager 1 made a disturbing discovery, altering its course toward Earth. But what exactly could this discovery be? Could it be proof of extraterrestrial existence, an incredible phenomenon, or something even more unimaginable? In this research, we will explore these thrilling findings as Voyager 1 has just made an alarming discovery that suddenly caused it to turn toward Earth. Records from the Voyager twin probes suggest that if certain celestial events hadn't aligned, two of the most remarkable rockets of all time might never have left Earth. In this case, it was the four largest planets aligning in our solar system nearly 50 years ago. These planets were slowly coming into alignment in a way that had last occurred during Thomas Jefferson's administration in the early 19th century. This exciting planetary arrangement largely went unnoticed until Gary Flandreau, a doctoral student in aeronautics at the California Institute of Technology, recognized its significance. Back in 1965, when space exploration was just beginning, Flandreau worked part-time at NASA's Jet Propulsion Laboratory in Pasadena, California. He was tasked with determining the most efficient way to send a space probe to Jupiter or even farther, to Saturn, Uranus, or Neptune. Using a simple pencil, he carefully plotted the orbital paths of these massive planets and made an exciting discovery. In the late 1970s and early 1980s, all four planets would align in such a way that they could be visited in a single mission. This alignment meant that a spacecraft could use the gravitational pull of each planet to slingshot itself to the next, significantly reducing travel time. Flandreau found that this alignment could cut the flight time from Earth to Neptune from 30 years to just 12 years. However, there was a catch. This planetary alignment only occurred once every 175 years. To take advantage of this rare opportunity, a spacecraft would need to be launched by the mid-1970s. NASA seized this once-in-a-lifetime chance and built spacecraft to embark on the journey, Voyager 1 and Voyager 2. These twin spacecraft were launched on an extraordinary mission to explore the outer planets of our solar system. Thanks to the alignment of the planets and the visionary calculations of Gary Flandreau, the launch of the Voyager twin probes on September 5, 1977, was truly remarkable. From Cape Canaveral in Florida, Voyager 1 embarked on its grand adventure into space, launched by a powerful rocket called Titan IE Centaur. Just 15 days earlier, on August 20, 1977, Voyager 2 had been launched. Voyager 1 took a shorter route, beginning its journey into the vast universe. Their primary mission was to explore the massive gas giants in our solar system, including Jupiter and Saturn, along with their numerous moons. However, these daring space probes exceeded all expectations. They ventured far beyond, pushing the limits of exploration, traveling farther and longer than any other spacecraft in history. They broke numerous records on their remarkable odyssey, going beyond anything humans had ever created before and entering a region known as interstellar space, a completely unknown territory within our galaxy. These exploratory spacecraft, Voyager 1 and Voyager 2, are now more than 12 billion miles away from us. Despite their immense distance, they continue to astonish scientists with the remarkable discoveries they make. Most recently, they made a discovery so startling that it has taken everyone by surprise. The Voyager twin probes have achieved numerous truly remarkable accomplishments. Decades ago, they studied the moons of Jupiter and Saturn, shocking scientists who initially believed them to be dull and cratered, similar to our moon. These moons turned out to be vibrant centers of interest. Voyager 1 made history by becoming the first of the twins to fly by Uranus in 1986, and just 3 years later, it passed Neptune, an achievement unmatched by any other spacecraft. As these spacecraft continued their complex journey, NASA used innovative techniques to keep them operational. They deactivated unnecessary components, such as extra heaters and systems, to conserve power. The goal was to keep the spacecraft functional until at least 2025. For the dedicated scientists and engineers who have been part of this incredible mission since its inception, it has been a mix of emotions. Their hard work has paid off, and just when they thought the Voyager missions were nearing their end, a shocking discovery emerged from the depths of space. At the beginning of their grand journey decades ago, the Voyager spacecraft amazed experts by providing the first close-up views of the moons of Jupiter and Saturn. These moons, which astronomers had assumed to be dull and heavily cratered like our own moon, turned out to be dynamic worlds. Voyager 1 reached Jupiter in March 1979, just a year and a half after its launch. Voyager 2, following a slightly different trajectory, arrived in July of that same year. Each spacecraft was equipped with special cameras that used filters to capture full-color images. These cameras were designed to rotate through space at a rate more than 100 times slower than the hour hand of a clock, ensuring that the images they captured were clear and sharp. During their mission, the Voyagers took more than 33,000 pictures of Jupiter and its moons, each revealing new and fascinating information. For example, Europa, one of Jupiter's 53 named moons, was found to have a cracked, icy surface estimated to be more than 60 miles thick. As the spacecraft departed from the Jupiter system, they gained a speed boost of 35,700 miles per hour from a gravitational slingshot, a crucial maneuver that propelled them closer to interstellar space. At Saturn, the Voyagers went their separate ways. Voyager 1 passed through Saturn's majestic rings, enduring thousands of impacts from tiny dust particles before flying by Titan, a moon surrounded by an orange haze, and continuing northward out of the planet's rings. Voyager 2 continued its mission, reaching Uranus and Neptune in 1986. During its visit to Uranus, Voyager 2 discovered 10 new moons and confirmed that the planet had rings. However, Voyager 2's achievements were overshadowed by tragedy. Just days after its closest approach to Uranus, the Space Shuttle Challenger tragically exploded shortly after liftoff, killing all 7 crew members including Krista McAuliffe, a teacher from New Hampshire who was set to become the first civilian in space. 3 years later, as Voyager 2 flew over Neptune's beautiful blue methane atmosphere, it encountered the fastest winds ever recorded on any planet in our solar system, reaching speeds of up to 1,000 miles per hour. Neptune's largest moon, Triton, turned out to be one of the coldest places in our solar system, with surface temperatures plunging to a bone-chilling -235 degrees Fahrenheit. The moon's frozen volcanoes were another rare discovery, spewing nitrogen gas and particles as the spacecraft's plasma wave instrument detected a strong solar flare between April 9 and May 2013. This event caused nearby electrons to vibrate, indicating that Voyager 1 had entered a region of higher particle density than that found within the heliosphere. At first, it might seem surprising that electron density is higher in interstellar space than near the Sun. However, researchers explain that the electron density at the edge of the heliosphere is much lower than on Earth's surface. By analyzing Voyager 1's data, scientists pinpointed the spacecraft's exact exit date from the heliosphere as August 25, 2012. This conclusion was based not only on electron movement but also on measurements of charged solar particles gathered by the spacecraft on that pivotal day. For the Voyager team, this announcement was a source of great pride and excitement. Susan Dodd, the mission director, described it as a monumental achievement in space exploration. For decades, the twin Voyager spacecraft had defied expectations, continuing their mission far beyond their original purpose. Their transition into interstellar space marked humanity's first step into the vast, uncharted regions beyond our solar system. Now, with Voyager 1 having transmitted unusual data back to Earth, scientists are on high alert. The spacecraft, which has continued to provide groundbreaking discoveries even after 4 decades in space, may have detected something unprecedented. What could this newfound signal mean? Some speculate that it could be evidence of an unknown cosmic phenomenon, while others wonder if it could suggest extraterrestrial activity. Whatever the case, Voyager 1's latest message has reignited curiosity and excitement within the scientific community. As researchers analyze the data, they remain hopeful that Voyager 1 will continue its historic journey, offering humanity a glimpse into the mysteries of deep space. The spacecraft, despite its age and distance, still has stories to tell, stories that could redefine our understanding of the universe. Communicating the group's satisfaction, Ed Stone said, "We are satisfied to have been ready to continue working with the Pilgrims and to see it accomplish the striking achievement of entering interstellar space." Ed Stone, a vital figure in the Voyager missions all along, underlined the significance of this accomplishment in propelling our comprehension of space. He said, "Voyager 1 has led us to new discoveries by providing us with the first perspective on this new area, expanding our scientific knowledge of energy and radiation in space." Voyager 2 also crossed into interstellar space in November 2018, venturing into an unknown region beyond the Sun's protective bubble, which shields us from cosmic radiation. However, the truly astonishing news comes from Voyager 1. After an incredible 46 years, NASA's Voyager 1 spacecraft, the most distant human-made object in space, continues to send valuable data back to Earth. Despite its extraordinary distance of over 14.7 billion miles, the spacecraft remains functional, even though its primary mission concluded long ago. Here's where things get truly fascinating. Voyager 1 recently made an extraordinary discovery that has left scientists both puzzled and deeply concerned. As Voyager 1 traveled through space, something unusual happened. It began sending data back to NASA, revealing an anomaly in its trajectory. The data it transmitted indicated signals containing information about an unknown phenomenon that defied explanation. This anomaly appeared to suggest the presence of a massive, previously undetected object exerting a significant gravitational pull, distorting the spacecraft's path. This discovery has shaken the scientific community to its core, igniting a storm of speculation. Could it be a rogue planet, a black hole, or something even more extraordinary? The implications are staggering. If confirmed, this newly identified object could drastically alter our fundamental understanding of the universe. NASA has assembled an emergency team of scientists to investigate further, utilizing all available resources to analyze the data and potentially redirect Voyager 1 to gather more information. This stunning twist in Voyager 1's journey serves as a reminder of the vast mysteries that lie beyond our planet and the relentless spirit of exploration that drives humanity to seek answers in the far reaches of space. The spacecraft, equipped with 3 radioisotope thermoelectric generators, had an expected operational lifespan of 4 to 12 years. Amazingly, Voyager 1 has far exceeded expectations, continuing its mission for an astonishing 45 years. Unlike solar panels, these radioisotope thermoelectric generators produce energy by harnessing the heat generated by the radioactive decay of plutonium-238. Despite its impressive resilience, NASA estimates that by 2025, the Voyager spacecraft may no longer be able to generate enough power to operate its instruments and send data back to Earth. During routine communication with Voyager 1 via NASA's Deep Space Network, something extraordinary happened. After more than 40 years of continuous data transmission, NASA's computer systems on Earth began receiving a mysterious signal that raised concerns. For the first time in its mission, Voyager 1 suddenly halted its journey and performed a complete 180-degree turn. The discovery from Voyager 1 is resonating throughout the scientific community. Researchers are delving deep into the mystery of what could be responsible for the gravitational anomaly. The implications of finding a massive, previously undetected object so far from Earth are profound. While it could potentially challenge some of the core concepts of astronomy, it also opens the door to new possibilities never before considered. Scientists are now racing to collect as much data as possible, analyzing the signals sent back from Voyager 1 to determine the nature of this mysterious object. Whether it is a rogue planet, an unseen stellar remnant, or an entirely new class of cosmic body, this finding has the potential to reshape our understanding of space itself. Many in the field are drawing parallels to the discovery of exoplanets, planets outside our solar system, which has been one of the most exciting areas of space exploration in recent years. While this object detected by Voyager may first not fit the typical profile of an exoplanet, the similarities in how its gravitational influence appears to be altering the spacecraft's trajectory have led some researchers to speculate that we could be witnessing the early stages of a much larger cosmic revelation. The discovery could prompt further investigations into the existence of dark matter and dark energy, as well as the possibility of hidden objects that are not yet detectable by conventional observational methods. The data that Voyager 1 is sending back has also sparked debates within the scientific community about the need for more advanced space telescopes and probes capable of detecting such phenomena in real time. The current generation of space observatories has limitations in terms of how far they can see and the level of detail with which they can observe distant objects. However, with recent advancements in technology, there is hope that new instruments will allow for more detailed exploration of space, particularly in the outer reaches of our solar system and beyond. This unexpected development with Voyager 1 has highlighted just how much remains to be uncovered in the vast expanse of space. Furthermore, this discovery has prompted NASA to reconsider the future of deep space missions. While Voyager 1's primary mission was considered complete decades ago, this revelation has reaffirmed the value of long-duration space exploration. The longevity and resilience of Voyager 1, still transmitting valuable data after so many years, demonstrate the importance of investing in spacecraft designed to withstand the harsh conditions of space for extended periods. As we venture farther into the universe, the lessons learned from missions like Voyager 1 could pave the way for even more groundbreaking explorations in the years to come. While the exact nature of the anomaly is still under investigation, this new twist in Voyager 1's mission has reignited the curiosity and excitement that space exploration always brings. It serves as a reminder that space is far more mysterious and full of surprises than we could ever imagine, and that our quest to understand the universe is only just beginning. Every new discovery, whether big or small, brings us one step closer to unlocking the secrets of the cosmos. It seems like the passage already tells a complete story about Voyager 1's unexpected anomaly and its implications for space exploration. However, if you'd like me to continue, I can expand on possible next steps, scientific reactions, or potential future missions inspired by this discovery. Would you like me to? 1. Speculate on what the anomaly could be, e.g., a rogue planet, dark matter interaction, or an unknown force? 2. Describe NASA's possible responses, e.g., how they might redirect Voyager 1, send follow-up probes, or upgrade observational tools. 3. Explore the broader impact on space exploration, e.g., how this could influence future deep space missions or change our understanding of interstellar space. 4. Write a fictional continuation imagining what Voyager 1 might encounter if it keeps moving forward.